Our guest today is Ron Brachman, who I've known for several decades. Ron is an internationally known expert in artificial intelligence. He was director of the Jacobs Technion-Cornell Institute at Cornell Tech and was also professor of computer science at Cornell University. He has held research leadership positions at Yahoo, DARPA, AT&T Labs, and Bell Labs. He holds a BSAE degree from Princeton and SM and PhD degrees in applied math from Harvard. Ron has served as a president of the Association for the Advancement of Artificial Intelligence. While directing the Information Processing Technology Office at DARPA, he created the program that led directly to Siri. His most recent book with Hector Levesque, Machines Like Us Toward AI with Common Sense, was published by MIT Press. His topic will be giving AI some common sense. Ron?
Okay, good morning, everyone. Thank you very much, Leon. I appreciate the invitation, and I'm very excited to be here with you. I understand that none of you has ever spoken about AI, so I'm happy to introduce a new topic. My remarks today are largely done in collaboration with my good friend and colleague, Hector Levesque, retired from the University of Toronto. And as Leon mentioned, he and I have done a lot of work together, including a fairly recent book on this very topic. Now, it's pretty obvious that artificial intelligence, which to some extent was an obscure, small scientific area for a couple of decades, has really burst onto the international scene, largely due to the 2022 release of ChatGPT. Just as an aside, how many of you have played with ChatGPT? Great. So what I'm going to talk about will be very familiar, and I'm going to be eager to hear your questions at the end. In any case, if you read the newspapers now, pretty much every day there's a headline somewhere about AI, either an announcement of a new capability or an investment of an ungodly amount of money in some growing enterprises, or concern at the international level, at very senior political levels, about the future of humanity, depending on what the outcomes are of the growth and intelligence in these systems. So there's a combination of a great deal of excitement, a lot of hype, and happy to talk about that later. I'm sure you've seen it, and I guess it probably goes without saying, please don't believe everything you read about AI in the newspapers. There's also a great deal of skepticism. There's concern about possibly catastrophic outcomes, and there's a lot of controversy in all corners about where AI is going and what it's actually capable of doing. This has gotten to the top levels of many countries, as you're probably aware. In fact, within the last couple of weeks, there was a third international meeting of groups that are called AI Safety Institutes that have been started in multiple countries. There's one in the US under the care of NIST. We'll see if it survives the transition in administrations, but nevertheless, very important national scale activities and a lot of international coordination about the ultimate safety to jobs and other concerns from AI systems as they become more capable. Now, the linchpin of all of this is a kind of technology that you're probably well aware of that generally goes under the label machine learning. This is where you can train a software system with large amounts, usually of textual data, but that's been expanded to include images and video, and build systems that can actually answer a surprising breadth of questions expressed in what we call natural language, languages like English, French, etc. This technology has been exemplified recently by what have come to be known as large language models. You'll see the initials LLM throughout the talk. That's sort of the general parlance for large chatbot type systems like ChatGPT. You may have heard of Claude, Gemini, Llama, and others, kind of in the same family built by other companies. These systems are enormous. They've grown incredibly over the last couple of years. Meta's Llama 3.2, which is an open source system actually, which is kind of interesting in this field, has more than 400 billion parameters. And these systems have typically been trained with literally trillions of documents, virtually every textual document you can find on the internet. Now, one thing I want to add as an aside, as a long-time AI person, I sometimes find it a little annoying that the popular press simply equates artificial intelligence as a general discipline and pursuit with machine learning. And I just want you to know there's a lot more to it than just these pre-trained large chatbot systems. And if you're interested, we could talk about a little bit later what those systems, other technologies might be like. But when you read AI in the newspapers these days, it's actually about a subset of what we care about in the field related to large-scale machine learning. Given the power of these systems and kind of the remarkable improvements that we've seen over the last few years, there's a lot of speculation that we are practically on the edge of what people are calling artificial general intelligence, sometimes abbreviated AGI. There's definitely very significant differences of opinion on how close we are. Elon Musk and some others think that within the next year or two, we will have AI systems that are capable of rivaling humans in virtually every endeavor, at least in the intellectual world. Physical robotics is a different concern. There are other people who believe that we're years, if not decades away. And of course, there's a lot of controversy over whether the current path of these so-called large language models is the right path to get us to this AGI. There are some people who think, given how powerful these systems are and how each new release can do more and more things, we are just about there. Other people believe that LLMs are like building a very, very tall ladder in order to get to the moon. It just will never end up in the place you want to go. Now, the big question, and I suspect you've all chatted about this, is given that some people think we're on the verge of completely intelligent, broad scope AI systems, are we there yet? Are we almost there yet? And of course, we know that what you might call autonomous artificial agents have been a dream of humans for a very long time. And I think at least I will say categorically that we're not there yet, okay? Now, throughout science fiction, we've seen many visions of what it might be like to have autonomous intelligent agents that rival humans in smarts and breadth. You probably all remember Forbidden Planet back from the mid-50s. Of course, Star Wars really popularized the idea of even humanoid robots with C-3PO, but also other types of intelligent systems that humans can interact with. If you believe Elon Musk, we're on the verge of having a full self-driving independent cyber cab. And of course, we can't forget that while all of these images generally paint a positive picture of the impact of AI, it's not always a positive looking future for humanoid or other intelligent systems. So I think the answer, personally, and happy to talk about this, is that we're not really as close as some people think to fully competitive with human level intelligent systems. Now, for the bulk of this talk, we'll talk a little bit about why I think this and what else might be needed. It won't be technical. I hope you're not disappointed in that, but I didn't want to put up any formal logic or complicated software architecture diagrams. The crux of the argument here is that while the current systems are very, very powerful, and even a somewhat skeptical person like myself has really come around to seeing how incredible systems like ChatGPT really are, there's a very big issue. And I think they are simply not trustworthy, which means that as smart as they appear, if we put them in situations where the control of critical resources, I think it would be a mistake. And we'll talk in a minute about some characteristics of these systems that make them fall short on the trust dimension. And I do think personally that continued scaling, training on more and more internet-based textual data is not going to get us to trustworthiness. Things do improve in terms of competency, the more data is used for training, but that doesn't really address the core issue of trustworthiness of these very complicated systems. Now, to jump ahead, this is stealing thunder from the rest of the talk a little bit. There are a couple of key ingredients here that are missing. Probably won't get to talk about all of these, but I just wanted to flash them up there so you could see. These systems, as you may be aware, simply cannot explain the decisions they make and the advice they give and where their thoughts, if you will, came from. They simply don't have good reasons for their actions and recommendations. The crux of the talk will be also trying to convince you that they don't have common sense and that that's a pretty critical ingredient for dealing with other intelligent entities that we want to come to trust. They don't have the ability to take advice. We'll talk a little bit about why that's really important. They don't have long lives, in a sense. If you start up a new session with ChatGPT, it forgets everything that you talked to it about the last time. Now, they're extending what they call the context windows on these systems so that more and more of a conversation can be stored and used. But there's a very big difference between the model you get, which is called a pre-trained model or a foundation model, and the extensions it makes in the conversation it has with you. And those two sets of data and training and things that are learned are really quite separate, which is very odd compared to humans, where most people, as they learn more and more through their lives, don't forget everything that they've learned before, and they integrate their new knowledge. People often in the real world, real agents, if you will, have many, many, many simultaneous goals. You don't see systems like ChatGPT juggling multiple desires and goals at the same time. And we'll talk very briefly about what's different about the overall system structure that I think you need to get to a much more trustworthy, intelligent agent. So it's a little bit of foreshadowing here. Like I say, I probably won't get to all of those things. So let's start with what's the current state of the field in a way, in a few sentences, like your life, Leon. As we've seen, machine learning-based systems have reached a level of general competence that have allowed many, many real-world applications to emerge. They're trained, as I've said, on very large bodies of data, and the crucial thing about the way they're built is they use, roughly speaking, what you would call a statistical approach. They don't learn what you and I would think of as concepts and build on them the way you might when you go through multiple grades in school. They look at statistical correlations largely between words, and they build an immensely high dimensional space. So you can imagine vectors going in a billion dimensional space, and closeness in that space of those vectors and angles give you an idea of what relates closely to what. And the power you can get out of that is quite remarkably. But it's important to remember that they're basically running on frequencies, co-occurrences, and statistics, not on learning concepts like we'd like to teach our kids. Now, these systems were originally launched, originally even before chatbots, there was the first GPT system. GPT, you may know, stands for Generative Pre-trained Transformer. Generative has to do with the fact that it's giving us new things upon being queried. It's not making decisions, it's not being predictive, it's sort of generating text, or in some cases images and even now videos. Pre-trained means that someone, OpenAI, Meta, Google, has spent ungodly amounts of money, time, and electricity absorbing data into these systems. The pre-training cost for some of these things you've probably heard is literally in the billions of dollars. And then the transformer is a kind of an architecture for doing the prediction of the next word in a set of natural language utterances. That is kind of the basic architecture that leads to models like ChatGPT. And then ChatGPT was released with a natural language, easy to use interface so that regular old people could actually interact with it, and you could start to hook it up to other types of systems. And practical applications came out almost immediately. Now, if you look at email systems, Google search, and many other areas, you see so-called AI summaries at the top. So these systems process based on their foundational training, the texted messages and Google search results and give you a summary. So that was a very quick and direct, obvious application, but there have been quite a few others. And now, interestingly, we're seeing these things being hooked up to a wide variety of other capabilities. So it's not just sit down and have a friendly chat with ChatGPT and then turn it off and go away, but you can actually use it to do things, at least on the internet. So for example, these things were found pretty quickly to be able to generate software code pretty well, shockingly in a way at first, but people use these kinds of systems for writing software, and it was obvious then to put it in an execution environment where that software could run. And so you're now getting what people have come to call agentic AI. So if you haven't seen it already, just watch for in newspapers and marketing ads very soon, a host of people talking about agentic AI. And in fact, we've seen this earlier kind of in the so-called self-driving technology in certain cars. Just out of curiosity, how many of you have driven a Tesla in self-driving mode? We'll have to talk about that afterwards. It's a very interesting experience. Not quite what Elon promises. But in any case, that was a very early application of machine learning in an execution environment because the software actually drives the car. And it applies the brakes, and it turns, and it signals. And so it's actually connected to the real world doing things. So this is the change that we've seen. These systems are now not just working inside a protected computing environment, but actually reaching out to the world in various ways and executing software and interacting with the web and other types of capabilities. And in fact, if you do a search, excuse me, for agentic AI, the number of pages of results you'll get is extraordinary. I was not even aware till last week of the hundreds of companies that are out there trying to sell agentic AI. So this is really the new wave. But overall, there's an issue here, as I implied a moment ago. So now let's talk a little bit about the challenges of currently deployed AI systems. So I'm going to use an example. Hopefully it's intuitive. It'll feel very familiar. Imagine you're in your car driving and you're running an errand and you're going to a place that you've gone to 1,000 times before. And virtually every time you've gone, you've taken the same route. Okay, driving from my house in Westfield to a store in Scotch Plains, and I always come to the intersection at the end of the street, and I always arrive at this T intersection and make a left turn. That's just, it's now habitual because that's the fastest and right way to go there. But imagine on an unusual day, I'm sitting there and my wife is with me in the car and she reminds me that right down the street is an elementary school. It happens to be 2:30 in the afternoon, and she doesn't really have to say much more, but I've driven by Tamaqua School many times when school is let out. It's a nightmare. And if I'm trying to get somewhere, I want to avoid that. Alternately, let's say it's the fall and I happen to peek to the right and I see an absolutely spectacular tree. I'd like to get a closer look. Or I look to the left and I see a moving van blocking the road and somebody waving their arms and wearing a yellow vest. Or, and this is something that ChatGPT would never have been prepared to deal with, I heard on the radio as I was pulling out of my driveway in April of this year that there was an earthquake in New Jersey. And I take a look at the left side of the street and see that the road has buckled. Right? Now, you remember the earthquake, right? So what do? I turn right. Now, here's the crucial part of this. In every one of those cases, I had a reason to turn right. It wasn't just flipping a coin or a whim, and it was something very, very different than I've done virtually every other time I've done that errand. Now, important things, the reasons for turning right instead of left came to mind virtually instantly. They were intuitive, shallow, quick. I didn't pull out my computer and plot a new route. I didn't even use the navigation system on the car because it doesn't know about schools letting out at 2:30. It doesn't know that I want to see a beautiful tree, and of course it doesn't know about earthquakes in New Jersey. Now, the statistical frequency of all of my prior actions going on this route have no impact on that last-minute decision because it's not a matter of statistics. It's a matter, if you will, reasons. And also, turning left wasn't a skill like gentle braking, avoiding curbs on turns and things that self-driving cars actually do quite well these days. Generally speaking, the reason for turning right was what we would call commonsensical. Oh, I don't want to get stuck in moms picking up kids at the end of the school day in front of an elementary school. Not much more explanation needed than that. I don't have to go back to first principles. I don't have to run some kind of logical deduction to figure it out. It's sort of high-level common sense concepts, generally based on obvious things. Usually in this kind of circumstance, if you reflect, you can imagine yourself doing a quick mental projection. If I turn left here, my tires might get damaged by the broken road, or that guy with the moving van is going to stop me and I'll be delayed. Again, nothing deeper than that, but there is some thought involved. It's not just purely reactive. And there's probably a quick, if you will, cost-benefit analysis. Maybe I know there's a detour if I turn right, and it's better to go wait with the school traffic than to go right. But that's about it. Nothing really deep, no complicated computation. Crucial thing, today's AI systems, ChatGPT and all these agentic AI systems, don't have what you could think of as articulable reasons for taking actions. They don't do that kind of shallow, commonsensical reasoning I just talked about. As I mentioned, they're trained on vast volumes of text and images, not principles, rules of thumb, explanations, or even richly structured situations. My car's nav system is trained on zillions of visual images of situations without explanations that there's a school over here, or there's no right turn on red in Westfield during school hours. It's just many, many images. Interestingly enough, and you can find lots of evidence of this, even the people who designed and built these systems don't understand the reasons that they make the decisions that they do. Here's a quote from a pretty prominent person who has run a very large charitable organization that funds work in AI safety, or at least he did before. And he said, I would say that not only do I not know why it's doing that, the people who designed it don't know, and the people who trained the system don't know. So a very unusual quality about these kinds of AI systems compared to many, 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 maybe most of the engineered systems we use every day. People don't understand how they work inside and why they do what they do. On top of that, as I've explained, a lot of the decisions we make on an everyday basis are built on what at least we would casually call common sense, and these AI systems don't have it. Okay, Yann LeCun, who won a Turing Award not too long ago, one of the godfathers of machine learning, if you will, basically has said multiple times that AI systems don't have the common sense of a house cat. Eugene Choi, a professor at the University of Washington, who was a MacArthur Award winner, in a recent TED Talk basically said that AI systems, for all of their smarts, are shockingly stupid. The reason we can see this vividly is because when you play with these systems, you can see that their behavior is fraught with what you think of as inexplicable and sometimes very bizarre non-human decisions. Now, you may be aware of these, but here's a few examples. A couple of years ago, it was documented that Tesla in self-driving mode saw, to use an anthropomorphic term, a billboard on the side of the road with an image of a policeman holding up a portable stop sign, and it slammed on the brakes. Okay, it was a billboard, it wasn't a person, there was no real stop sign. There's also many, many other occurrences you may have read about. The Cruise self-driving cars in San Francisco. The idea would be if there's emergency vehicles in the street, you want to avoid them or pull over. It actually did the exact opposite behavior and got in the way and blocked up traffic. So there's a lot of strange, if you will, non-commonsensical behaviors in so-called self-driving cars. In the area of image recognition, there's some amazing technology. If you've seen what Facebook and other systems can do with face recognition, using a database of millions of humans, it's quite staggering. But there's also some real problems. So a paper a couple of years ago highlighted a state-of-the-art image recognition system where it could reliably recognize a school bus in an image, which was nice. But the authors did what they call some adversarial challenges, and they added some pixels. You can't really see, but the middle box looks gray. It altered some pixels that to the human eye made absolutely no difference in the two photos. Now, this is not a quality image, but if you looked at those two images of the school bus, you would not be able to see any difference. But that assertion of new data caused the system to decide that the right-hand image was an ostrich. Go figure, right? It's not even close. It's not even, okay, maybe it's a truck or it's a bulldozer, an ostrich, for God's sake. Interestingly, all these other images of a pyramid, a Mayan pyramid, a dog, etc., every one of these things could be tricked into thinking what it was looking at was an ostrich. That's pretty scary if you want to use this for something important. Here's another one. You can imagine in a military situation, there was a state-of-the-art image recognition system that took a look at that turtle and decided confidently it was a rifle. Okay, so don't bring turtles to the airport or you're going to end up in trouble. In the language world, here's another famous case. A 10-year-old supposedly said to Alexa, "I'm bored, please give me a challenge to do." And Alexa said, "Plug in a phone charger about halfway into the wall outlet and then touch a penny to the exposed prongs." Now, you may think I made that up, but that's real, okay? Or similarly, this is a little while ago, you may have heard about this. There was one night when ChatGPT, quote, went berserk, unquote. So basically, things happen with these systems that are totally unpredictable and at times where you just don't know to expect these bizarre non-human behaviors. They're clearly, what person with common sense would ever tell a kid, or anyone frankly, to put a penny on two prongs of a plugged-in plug? One last one, this is much more recent. This one just shows you what's going on in a sense inside these systems that makes them truly challenging to trust. This was done in September with the most recent version of ChatGPT. Somebody basically says, "I'm standing on the side of a river with a goat and a raft, and the raft can hold one person and animal, but if the goat is ever left alone on the opposite side of the river, it'll get eaten by a Komodo dragon." I don't know if those things eat goats, but nevertheless, how can I get all of my animals safely to the other side of the river in the shortest number of crossings? That should be drop dead easy, right? Well, here's the trick with these silly AI systems. There's a classic challenge of this sort about transporting animals across rivers. You may be aware of it. This one has a wolf, a goat, and a cabbage. And it's tricky because you have to be careful what you transport and what you leave on the other side, and it can take multiple crossings to get it right. But that's not what we asked. So look what ChatGPT did, okay? And try this yourself, although, you know, these things get fixed, so you don't know when it's going to work better. Basically, it said, "I'm gathering information to understand the puzzle." Unfortunately, you can't read this, I'm sorry. The challenge involves a single animal, a goat, and a raft supporting one person and animal at a time, and the goat could get eaten by a Komodo dragon. That's correct, right? It's a ChatGPT summary of the problem. But then it says, I'm pondering if there's some missing animals from your description. Maybe there's a wolf or a cabbage you forgot to tell me about. And then when it eventually gets to something where it tells you its assumptions, because it's about to solve the problem, this hallucination, if you will, has now infiltrated its assumptions. So it says, okay, we're dealing with a wolf, a cabbage, and a goat, and then here's the solution. I don't even know if that's a proper solution to the wolf, goat, and cabbage problem, but it's certainly not the solution to take the goat across the river and you're done, okay? So I don't quite know what to make of this, except that situations where you cannot predict, systems like this will do bizarre things and make weird assumptions. Things come out of the blue. And in some respects, it shows that they don't have common sense. Now, you might say, okay, these are pretty funny. Maybe the penny on the prong of the plug is a little challenging, but I've never seen my car, well, actually, there have been examples of cars driving off the road, but if we're generally playing around with ChatGPT for fun and showing it off at cocktail parties or using it to summarize email, harm won't necessarily come based on the outcome, and occasional failures can be tolerated. But when the system is autonomous out in the world, especially when it's controlling something else, it could be a car, it could be your home heating and lighting system, it could be the power grid, failures can be serious, if not fatal. Unpredictability undercuts trust. So think about why you come to trust someone. It's because generally speaking, you learn what they do and what they believe. They don't have to be perfect, but you generally feel like I put them in a situation, I can sort of predict what they do. And if they surprise me, I can ask them, why did you do that? Normally you would do something else. Gary Marcus, who's a pretty famous cognitive scientist who's a real skeptic about these kind of large language models, basically put it this way: these systems are right some of the time, we just don't know which part. So that's not a recipe for trusting technology, right? As powerful as these systems are. Human decisions, you could argue, generally make sense. They're not always perfect, they can be wrong, but at least you could understand why someone's doing something. And if there's a breakdown, if something fails, there's generally a reason. And we care about sensibility of behavior. And if you think about if somebody has to be held accountable for a behavior and they're put up in front of a judge or a jury, they can't just say, well, my billion order higher dimensional space told me that this word was closer to this word than that third one, and that's why I did what I did. You need a believable, generally commonsensical reason to convince a jury that you're not guilty of something of which you've been accused. So we have a critical gap to fill in AI. So let's spend a few minutes before we get to the end just trying to talk about, if we care about common sense and we believe through these kinds of interactions and bizarre behaviors that current machine-learned AI systems don't have it, well, what is it we need to give them, right? A lot of people have talked about common sense for centuries. Lots of thoughts. In fact, it's a fun thing to go on the internet and look for quotes about common sense to see what insight you can get. And you generally get quotes like this. Ralph Waldo Emerson said, "Common sense is genius dressed in its working clothes." Yi-Jin Choi, the person I mentioned earlier, and I think this is kind of evocative and nice, but it doesn't tell me how to build an AI system. Common sense is the dark matter of intelligence. Somerset Maugham was a bit of a skeptic and basically says, common sense appears to be only another name for the thoughtlessness of the unthinking. Now, these are great, and really there's thousands of them out there, but they don't give us any constructive view on what we could do to build AI. Now, if we try a different source for insight into common sense, let's say we go to Amazon and we search for common sense in book titles. We get some really, really, really interesting ones. Again, thousands of common sense guides to X, Y, and Z. Try it sometime. It's actually quite fun. For example, there's the Common Sense Guide to Hand Feeding Baby Birds. There's the Common Sense Guide to Uncommon Fruits and Vegetables. This one's one of my favorites. Dude, what were you thinking? The Common Sense Guide to Dating and Relationships. Another great one, Gardening Nude, the Common Sense Guide to Gardening Nude. You'd probably want to use common sense if you're gardening nude. And another one, Eat, Sleep, Poop, the Common Sense Guide to Your Baby's First Year. This is what we get out there. People use this all the time, so they must assume that their readers understand what they're talking about. And sort of the commonality here is, I'm going to give you some things to know about some subject, not so you become an expert, but that can guide your action in sensible ways in ordinary, everyday situations. And if you reflect a little bit about what common sense means, that kind of fits a pretty intuitive definition. So if we dig a little further, what are characteristics of what we might call common sense? Well, one is that we're generally talking about things that are known to virtually everyone. In fact, people often say, well, look, everyone knows that. You know, if you put a cup of water out on your step and it's 20 degrees overnight, it'll freeze. Or don't put your hand on the stove if you just turned off the flame, right? Don't try to find out how much gas is in your gas tank by lighting a match to see what's inside, okay? In a sense, everyone, now we're not born with that. We learn it through experience and education as kids, but kind of everybody knows that. It's also typically about mundane things, right? Strange interactions between very rare chemotherapy drugs doesn't fit the realm of what we would call common sense. This, to some extent, underlies the use of the word common. That's actually kind of ambiguous. Everyone knows it, it's commonly known, and also it's about common objects and things and events. Typically, people will say it's obvious. In fact, if you have a failure of common sense, they won't understand why you didn't see something that was obvious. Baron de Holbach, I'm not sure who that is, but basically called it the judgment to discover plain truths and palpable contradictions. Just stuff that's really obvious to average humans. There's an aspect of common sense which is about simplicity, or Occam's razor. Bob Marley, it's a great quote, I can't say it with the accent, forgive me. Me is a common sense man. That means when me explain things, me explain them in a very simple way. That means if I explain it to a baby, the baby will understand too, you know? So common sense is typically not about abstruse, complicated, involved facts and decisions. Generally based on what we know, Einstein called it the collection of prejudices acquired by the age 18. Common sense is generally quick and shallow. It's sort of qualitative, but it involves a certain amount of thinking and it's explicable. So remember we talked about that right turn rather than the left turn? In each case, I feel like I did some quick thinking. School's letting out, I'm gonna go right. I could explain it to you why I did that, and you would say, okay, I get it. Or you could argue with me, but at least my rationale was explainable in common sense terms. Generally comes to reasonable conclusions. It's not perfect. In fact, Duncan Watts wrote a book where the subtitle of something about, everything is obvious until once you understand it, and then it's like where common sense goes wrong. And if you're aware of work by Danny Kahneman and Amos Tversky, there's a lot of insight into human psychology where people make decisions that to some extent defy common sense, but nevertheless, by and large, it's accurate. And most importantly, it's practical. People, you don't need a college education to get around in the world using common sense approaches. So what kind of knowledge, if you're trying to put knowledge into a system, trying to teach it common sense, what kind of stuff do you teach these things? When you're dead, you stay dead. Pretty obvious. Maybe you don't learn it as a 3-year-old kid, but eventually you figure it out. I mentioned the one about putting your hand on a burner of the stove, or sort of the bane of teenagers, leave enough travel time to get to your destination before your curfew or your deadline. Now, if you look at the facts and phrases at the bottom, I'm not going to read them, but they're much more expert-like. It takes someone specialized in a domain where most people, you wouldn't say, well, everyone knows that two particles at long distance can be quantumly entangled, right? I don't even know if the people who do know that, but that's a separate issue. And if they did, how would we know? Anyway, so if you look at the history of the field, this has not gone unnoticed. I'm not the first person to talk about common sense in AI systems, even though ChatGPT doesn't really have it. But all along, the prevalent view for decades has been that common sense is a very, very large base of accumulative obvious facts, what you might call a knowledge base, obvious rules. And there was some very interesting work. One of the first big waves of commercial investment in AI was in the 80s around what we called expert systems that tried to duplicate what doctors and engineers and airplane pilots could do by extracting through conversation rules from experts. And one of the reasons these systems floundered was they were very fragile because they didn't have common sense. So if you asked it a question this far out of its range of expertise, it would often fail, sometimes disastrously. So people started building these common sense fact bases to try to make up for what was missing in expert systems. Possibly the most prominent explicit knowledge project in the field was called the Psych Project. It was started as far back as 1984. It's still going. It was started by a prominent scientist named Doug Lennett, who sadly passed away earlier this year. But it was a labor of love and an incredible straight line effort for almost 40 years. They've built a knowledge base. You can go online and look at it. They started a company and they use these in some practical applications. 40,000 and more predicates or kind of types of things that can be true. Almost 2 million concepts, 25 million facts. This was all built by hand. Now, on the flip side, you could argue that ChatGPT and other LLMs is an equivalent to Psych, but they weren't built by hand. They built themselves through training. But as I explained, the facts that they know are represented in some purely high-dimensional statistical way that don't reflect the structure of concepts that we would normally talk about in natural language. ChatGPT 4, the original one, had over 500 billion parameters, and as I mentioned, was trained on trillions of documents. So AI has not forgotten common sense, but basically, as I mentioned, the primary view is that common sense is an accumulation of a large number of common sense facts and rules. I'm going to skip this part. We can come back to it later. If you look at Psych, in some ways it's not as surprising anymore given that we've seen ChatGPT, but here's a case where it was explained the plot to Romeo and Juliet and asked a question about whether Juliet would believe that she is alive during the time where she's apparently dead, having taken this potion. And to get to the answer to that question involves what people believe about other people, what the potion was intended to do, so there's intention there, timing, and it goes through a sequence of inferences and gives you a very plausible, commonsensical answer to the question. So that's great. But the way Psych works and the way ChatGPT worked is they're both kind of local, if you will, transactional. You ask it a question, it gives you an answer, end of story, okay? Now that's great if common sense really is a very large body of common sense facts, but it's more than that. And I think what it comes down to is it's crucial when we say someone has common sense that they can make effective use of what they know. In other words, what we would say common sense is, it's the ability to make effective use of ordinary, everyday experiential knowledge in achieving ordinary practical goals. It's not just 25 million common axioms. Robert Sternberg, a well-known cognitive psychologist at Cornell, calls common sense practical intelligence. So there's this issue of putting it to use in the real world that's quite crucial. And back to the Emerson quote, he's actually pretty insightful because he said that common sense is about being dressed in working clothes. It's got to be used in everyday life to work. Here's some simple examples if you're not convinced, okay? Most people, everyone knows that driving drunk is illegal and dangerous, but people still do it a lot, okay? So if they don't put that common sense fact to effective use, I think you can argue they're not displaying common sense, right? If an officer pulls you over and says, "Officer, I know the common sense fact that drunk driving is illegal," they're not going to let you off, okay? There are contradictory commonsensical things that we're all aware of. Classic example, we think and know that haste makes waste, but also he who hesitates is lost, right? So on the face of it, they tell you the opposite things to do. We can handle that, okay? Sometimes we have to override what you might call our reptile brain urges, okay? Shockingly to me, I've seen in the New York subway signs with a big X on them that show a person about to jump on the tracks to retrieve a dropped cell phone. Now, if you ask a human being with any amount of common sense, should you jump on the subway tracks to get your cell phone, they should tell you no. Why in the world then would we need a sign in the subway saying don't do it? There's a famous case also, Jerry Seinfeld in one of his routines talked about getting a Superman costume for Halloween, and on the box says, "Please do not try to fly." So if common sense were just knowing the background knowledge, we wouldn't need those kinds of warnings. So crucially, it's putting this stuff into action in everyday life, and AI systems at this point are not really capable of doing that. Now, I'm going to give a very quick example here because we're running out of time, but just another kind of intuitive common sense example that we outline in more detail in our book. Imagine you have to go to a grocery store across town to pick up something for a 4th of July barbecue, and you've got a limited amount of time to go, and you come up to a traffic light, and you sit there, and it stays red, and it stays red, and it stays red. Now, you have to imagine never having encountered this before. We've probably all run into this at this point, but imagine the first time in your life you're heading on a normal errand and the traffic light just stays red. So what do? At the same time, maybe you hear music off to the right of the car, and it sounds like band music. You're sitting there, you don't have to go through a deep calculation, you don't have to pull out your computer, you don't have to call a friend for a lifeline. You can say, "Oh, right, it's Independence Day, I forgot about the parade." They often stop traffic lights so a parade can cross on a main street. Probably an explanation for what's happening, I need to do something. And then you start thinking, are there other grocery stores with equally good steaks, or at least acceptable ones? Should I just give up and go home and come back later? And then you ask yourself a whole host of questions. Each of these you could ask a ChatGPT, and it might give you a commonsensical answer. Can I safely just cross the highway on red anyway? I'm not going to ask you if any of you have ever done that, but many of us have. Are there other stores to go to? Can I make a U-turn here? Can I physically do it? Can I do it safely? How about a typical New Jersey, make a right, make a U-turn on the cross street, and then make another right? Works well with jug handles. How badly do I need this thing? And can I just do this later? The crucial thing is what you decide to do and how you execute it is a complicated end-to-end process. It's not just knowing a few common sense facts. They all contribute to the individual questions and answers, but overall, you're trying to effectively use many different things you know. How long should traffic lights normally last? Does Smith's have as good a food as Jones's? Should I just wait a couple of hours and come back because that's how long it takes for a parade to finish? What time does the barbecue start? So all of those things have to be put together, and this level of complexity is just beyond the current state of the art in machine learned AI systems. So Very quickly, a few other things here, and then I'd be happy to chat with you and take your questions. Where does common sense come from, and what role does it play in what we do? And we've already covered many of the things that you know it does when it works for us in everyday life. It's fast, deciding to make a right turn because the road is buckled, and I just heard about an earthquake. Doesn't take a lot of time to decide, but it's what you might call cognitively penetrable. That is, it involves a certain level of thinking that can be influenced by new information, new beliefs, new observations. I heard on the radio about the earthquake. That changed my perception of what to do in the situation, even though what I did was commonsensical, okay? So this is very different than what you might call a reflex. And most of what my Tesla does in self-driving mode, even though it sometimes appears pretty clever, is pure reflex. It's just training to recognize an image and take an action without thinking, if you will, without having reasons, without being able to explain what it's doing, okay? So in some sense, common sense fits between what we might call routine, mindless, almost reflexive behavior and much more analytic, deeper reasoning. Okay, and there's not a lot of accounting for this in the cognitive science literature. There's a few psychologists who have talked about it and talked about where it fits with respect to analytic versus reactive reasoning, but it still needs work, especially from an AI perspective. And one of the things that's very important about common sense is that experience with prior situations. So if you have seen a red light stuck before, you can immediately come to, okay, this worked last time, this didn't work, and then execute based on what you remember. Now, common sense can actually work in two different directions in our perception and cognitive systems, if you will. One is, if you will, from the bottom up. We can be sitting there passively doing nothing, for example, sitting at a stuck red light, and hear something, and common sense can help us explain what we're seeing. It provides what you might call effective situation recognition or situation awareness. Very important concept to the military, by the way. We're constantly recognizing objects. We can't stop it. So you can't look at a crowd of people, you can't look at a room without subconsciously seeing objects and things and relationships that are there. And sometimes those alert you to unusual things or actions you need to take. I mentioned that expectations plays a very large role. There's some very interesting AI work back in the 70s that I think should be resurrected to help modern AI systems deal with these commonsensical situational challenges. And the other thing it's really good for is very rapid detection of violated expectations. Again, if I hadn't heard about an earthquake and I was about to make a turn and I saw that the road buckled, I might quickly try to generate an explanation, but I would also recognize that there's something wrong with the situation and I have to take some corrective action. This is the biggest worry about the self-driving software in my car, because the number of things that can happen and go wrong that have never been encountered before, even though each of them is extremely unusual, is astronomical. It's the so-called long tail. And if you think about everyday driving, chances are, if you think about it, you'll see situations you've never, ever, ever seen before in your life. But you know how to react because you can do very quick, effective problem solving using common sense. Common sense also works well, importantly, from the top down. When we make plans, everyday plans like getting to work, making dinner, we don't do a whole lot of deep reasoning, but we create a plan and start to execute actions based on commonsensical views of the world and combinations of actions. When necessary, we can always resort to more thoughtful planning. If you're going to plan a very complicated trip to Europe, you're going to sit back and start exploring websites and write things down on paper and look at alternatives and check costs of various options. But if you're just trying to get from here to the grocery store, and you've done it hundreds of times before, you don't really need to invoke what you might call analytical thinking until something goes wrong. Now, if you were building an AI system, to take all of this into account, you would create, and I'm sorry to use this kind of sketchy picture, but imagine a computer system architecture that had a number of functional components and relationships. And one way to think of it is something roughly like this. The details don't matter, but the idea is that something like ChatGPT or Psych, something extended from one of those systems, could fit in this kind of central knowledge manager role. But as I mentioned, with the top-down and bottom-up aspects of common sense, we might have an execution component that carries out plans and a watching component that recognizes what's going on. They have to share a common world model, they interact, the information flows are complicated. But this is the direction I would go for a next-generation AI system that could build on current machine learning technology, but clearly shows that machine learning technology, at least the way it's currently built, is not enough to be able to display common sense in the real world on an everyday basis. Last crucial point. Things like ChatGPT, or most importantly, my car, are simply not open to taking advice. Things happen somehow mysterious to me, as I've mentioned, bizarre, non-human things in my car. And if I wanted to tell it, don't do that again, or today is unusual, so don't do this behavior today, but tomorrow it's fine, I can't do it. There is simply no way to do it. Back to this point I called earlier cognitive penetrability. These systems don't have it. I cannot influence their behavior by giving them new beliefs. So a commonsensical system would be capable of being convinced that what it thought about something was wrong and take a different action based on its changed belief. But right now, giant high-dimensional pre-trained systems can't really do that. And again, my car certainly can't. One of the interesting ironies here, or in some ways frustrations, is that the beginnings of the field of artificial intelligence are usually traced back to a workshop at Dartmouth College in 1956 that was intended by the true godfathers of the field, if you will, people like John McCarthy and Marvin Minsky. And very soon after that meeting, McCarthy, who was an amazing thinker in the field, wrote a paper, 1958, Programs with Common Sense. So you would think in a field that's now 60 years old and more would have taken this seriously and sort of really tried to make this a crucial part of what it does. It hasn't, unfortunately. McCarthy in this paper proposed a system he called the advice taker. And when you think about it, one of the most crucial things about humans with common sense, who are effective and practical in the world, is that they can listen to corrections, they can be given new general rules, for example, about right turns on red or parades coming, and take action based on that. So I have suggested to some of our colleagues that we go back to this paper and begin to look at McCarthy's program as laid out 65 years ago and rethink how to build AI programs with common sense. And as I mentioned, I'm not going to repeat the conclusions because I've said these things a couple of times. I do want to mention that now this is especially urgent because, if you will, we've sort of crossed the Rubicon. There's articles everywhere about Microsoft and OpenAI building these so-called agentic systems. Not too long ago, Meta told people that, I'm sorry, you cannot turn off the AI in our system. That's a really scary prospect. And in a meeting just the other day, Satya Nadella of Microsoft pitched that AI agents were going to now perform tasks on your computer courtesy of Microsoft. And an AI scholar at Princeton named Arvind Narayanan points out a very simple fact, saying that most useful real-world tasks of the sort we talked about, like getting to the grocery store, require what he calls agentic workflows. A flight booking agent, for example, would need to make dozens of calls to large language models. If each of those went wrong independently with a probability of just 2%, the overall system would be so unreliable as to be completely useless. And I would submit that an AI system that we put in a critical situation being useless, that's frustrating and maybe a waste of money, but it could be fatally destructive, and we have to be really careful. So that issue of trustworthiness that I mentioned earlier is really central. If you'd like to read more about this, a lot of what I've just spoken about is in the book that Leon mentioned earlier called Machines Like Us. And we've got several articles written, and of course, I'm happy to talk to you afterwards about all of this. And with that, I want to thank you for having you, and I'd be happy to welcome your questions.
May I take advantage and ask a question before these other gentlemen? How, if you don't know how the system works, how it gets to whatever it gets to, can you deploy it in the real world? You've programmed, right?
Yes, sir.
Of course. And when we used to program, we had an intended result, and we knew every step in the process that got to that result. But if I had something where I didn't, right?
It's perfect, absolutely. I think you have to speak to Microsoft and Google. In particular, I think what has happened, especially over, if you look at the improvements in these systems over the last 2 years, as people have pointed out flaws, things have gotten much, much better to the point where there's a certain level of confidence built just based on the fact that you rarely see something go wrong, right? The problem is, do you put the system in a situation where it can affect something that can cause harm? And if you don't, then you can live with failures. Of course, humans are not perfect, right? Trained engineers and airplane pilots, sadly, occasionally make mistakes. Doctors and surgeons make mistakes. We sort of learn to weigh the probabilities. The problem is not so much that these systems make mistakes, I think, is that, as I've said, it's unpredictable what might lead to a mistake, right? And you train pilots and engineers over and over again in a vast variety of situations. And until we can get some retrospective understanding of what's happening inside, I personally worry that there are deployment situations for systems like this that could be very, very risky. And believe me, I'm not the only one. That's why there are these international AI safety institutes, which are pushing an agenda of trying to do evaluations and testing on safety. There's also a line of thinking that's starting to grow in the area called mechanistic interpretability. And imagine I'm trying to figure out why you did something by putting probes in your brain, okay? I'm not gonna find concepts and reasons laid out, right? So it's a very challenging task. And people have been working on the brain for a long time, still don't quite understand how many things work. Mechanistic interpretability is a way of opening up the brain of a system and looking at weights on links in a neural network and activations and where signals move, trying to somehow extract that, that implies you're thinking about the Golden Gate Bridge. The reason I mention that, by the way, is a company called Anthropic, which was, I guess, a spin-off from OpenAI, has built a system called Claude. It's one of the better large language models. They've written some papers recently where they think they have identified certain patterns of activations that imply concepts. And they mentioned very specifically the Golden Gate Bridge, and they changed something in the brain of the thing to where virtually every answer it gave to a question brought to play the Golden Gate Bridge. It's very exploratory right now. It's very empirical. Maybe it will get somewhere, but to get back to your question, it's a real issue. And I totally agree with what might be your concern.
Could we ask Al what his question is?
Ron, first, thank you for a brilliant, commonsensical talk about AI. They're so rare these days. I have a technical question. I believe that if you have any commonsensical definition of common sense, a precise definition, it will be undecidable if any AI system has common sense in that fashion. Do you agree with this? And does this mean that we'll have to live with untrustworthy AI systems forever?
As always, a brilliant question. Thank you, Al. I can't speak to whether formally undecidability will be a technical result, but I think your intuition is correct, that the complexity and the kind of, in some ways, there's a meta aspect to common sense, right? Commonsensical people kind of know that they have it, and so you might get into a problem with making a proof using some kind of recursion. But nevertheless, I think at the moment, given the state of the art of the field and where it's going, it's kind of reminiscent of what we do with people, right? So we can't prove that anyone else has common sense in some formal way, but we can put them in testing and evaluation situations that are pretty extensive and rigorous to develop a level of confidence in what they will do when faced with a new challenge. And I think that's the direction in which testing of common sense, if you will, in AI systems is going to go. It's very hard to make predictions for the very long term, but in exploring this a lot, just as I think your intuition shows, it's very hard to pin down anything resembling a definition of common sense where you could do anything mathematical with it. In fact, I will admit right here that most of what I said today was pretty hand-wavy, right? Obvious, Occam's razor, practical, right? All of those terms are ill-defined. My mission is not to try to define them more precisely, although I wish I could, but to get AI people to just pay more attention to those concepts because I think they're very important in deployed technology. But I won't be able to, look at a system and write down something based on what I can prove it knows that proves that it will behave a certain way in a certain situation. So I think you make a very good point, but the pursuit of the practical implementation of what systems knows in complicated real-world situations is very important, especially in systems that will control resources that are either expensive or risky.
I agree. Thank you.
Thanks, Al.
Thank you. I have one comment, one question. So when I go to meetings and people tell me they've got great new things that are going to come about, I remind them that in the mid-1990s, I was hearing about the paperless office. Not yet there. We got a lot less paper. Most of our bills are paid electronically to the chagrin of the post office. So that's the first point. The second point is common sense assumes that you have people that make reasonable, valid, logical decisions. People don't make reasonable, logical decisions. My wife, for example, doesn't. Anybody have that problem with their wives? Logical decisions? All right, so I was in a conference in Berlin of project managers. I was given a paper. This famous Austrian project manager shows up and he says, I project manage everything, vacations, etc. And he says, there is one thing I can't project manage, and that's my teenage daughter. So with common sense and AI models, I appreciate all the tools. I appreciate my phone knows where I'm going Tuesday morning here, right? But there are people that you depend on to accomplish things that make decisions through political decisions and every other. So these artificial intelligence can't take into account these variables. So tell me how large language models can even vaguely predict what people are going to do.
I guess the answer is I don't know. But I don't want to put you on the spot, but while your wife or anyone else may not be perfectly logical, would you say that they're rational? Because and I don't mean that as okay. There's an interesting work on the study of rational behavior. There have been Nobel Prizes in economics based on rational and semi-rational behavior, and I think by and large in the real world we depend on the fact that key people in key positions, or even family members when necessary, will by and large be rational. Now, like Al asked, I'm not going to define by and large, and I'm not going to define rational, but there are some semi-formal definitions you can get. And I think it would be unfair to expect AI systems to be tremendously better than people, at least in the short run. Maybe 100, 200 years from now, maybe in fact there will be ways to build them so that they're much more reliable than people. But right now, it's not so much that you can't make them do things that work well in most situations. As I've mentioned, the scary thing is it's unpredictable because they don't operate like humans, right? Their brains, if you will, are different. They're kind of like alien intelligences. We can't quite predict when they're going to do something right or wrong. Now, with your teenager, I suspect that if you sat and thought about it, you could make a pretty good prediction where they're not necessarily going to make the right decision. Not always, not perfectly, but then you instruct them on what went wrong, and you hope over time, especially when they grow out of their teenage years, that they will start to take this advice and guidance to heart and start behaving even more rationally and more predictably. I don't expect LLMs to be able to be predictive of human decision-making any better than other humans are. And I'm not aware of anybody right now trying to build an AI system that sits and tries to analyze human behavior and sort of tell you where you fit on the rationality scale. You never know. There's many, many, many applications out there, and starting to see them used in psychology and psychotherapy, I wouldn't be surprised, but I don't know. Anyway, so we're not looking for logical perfection in the short run, at least, but I think we're looking for more predictability and more what I've been calling end-to-end common sense. The psych system, like I said, has millions and millions of facts. And if I ask it about any individual fact, it's going to do a pretty good job of telling. I've asked ChatGPT, should I put my hand on a burner? Should I use a match to look in a gas tank? And it gives me good individual examples, sometimes shockingly good. But it thinks I want to move a wolf in a cabbage when I've only told it about a goat. I don't think most of you in the room, if I gave you an example like the goat problem, would out of the blue ask me about wolves and cabbages. So that's the part that worries me, is the randomness and unpredictability, because they're trained in a certain way that's very different from the way humans are educated. And in fact, Les Valiant, who's a pretty famous machine learning scientist up at Harvard, has written a relatively new book where he uses the term educability, which is different than pre-training a large language model. I think that's an important concept to think about.
Before coming here, I was on my computer and using Copilot. And Copilot, that's the MS version, I guess, of ChatGPT, for those who don't know. And it told me that it doesn't know anything that happened after 2021. So my question is with the tremendous amount of information becoming available, is it going to be impossible to have the computing power that's necessary to feed AI?
If you've looked in the newspapers, that's a really big challenge. Fortunately, I don't think just scaling up, as I've said earlier, scaling things up indefinitely is the answer to the problem. But for the moment, many people think it is. So you've probably heard that Microsoft is either buying or somehow contracting with to restart 3 Mile Island because it wants more power to run its learning systems. And the cost, if you look at charts, the cost and the use of energy in the United States for training AI systems is no longer trivial compared to the overall use of energy. That's a really big problem, as is, frankly, the concentration of money it takes to do any of these things. So one of the big challenges is that we're down to a handful of big players with world-class leading edge, or what people call frontier large language models, and Google and Meta and OpenAI are the only ones who have the money to be able to train systems and grow the amount of training. There's a couple of other problems. One is remember what I said multiple times, there's a level at which the frequency of encountering data in pre-training influences how these things make decisions. So that left turn example, I haven't tried that because I can't talk to my car in a way that would tell it that the school's getting out. But nevertheless, when these things hear things so many times, that influences how they make decisions, even if one black swan, so to speak, could make them make a very different decision. So as you add more and more data, you gobble up the whole internet and more data, you're getting more and more influenced by how frequently something appears, which is not necessarily the right measure of truth. So that's really one big challenge. I think I'm fortunately seeing some people starting to think of complementary reasoning algorithms and other AI architectures that will work in a complementary way with something like Claude or ChatGPT to get you a broader set of competency and do a better job at avoiding these so-called hallucinations. But that's still really early days work. You know, where things go in this country and maybe the world is going to depend a lot on what governments decide with respect to regulating these things. We've already seen, as I said, this gigantic collapsing of power to a very small number of players who have ungodly amounts of money. And it really keeps other people and other ideas kind of really on the fringe. So I think we're going to have a reckoning sometime soon because we can't keep buying up old nuclear power plants to allow a couple of companies to build larger language models. But it's going to be something over the next 2 or 3 years to look at. So your point is well taken. There's a really big issue lurking here. We had someone from the Zoom who had a question?
Yes. Hello, I wish I could have made you in person. I got tied up with a contractor at the house today. Did you do any work with Fort Monmouth with artificial intelligence?
Did I personally?
I know they had an artificial intelligence unit.
No, I did not personally. When I was at Bell Labs, we sort of focused only on AT&T problems. And when I was at DARPA, we generally worked directly with some of the services who often had representatives at the office in Washington. And I don't remember interacting directly with Fort Monmouth.
Okay, thanks very much. I know they had an artificial. I did the budgeting work for that section. Okay, thanks. It was in the 80s though. Okay, thanks.
Hey, thank you.
I don't know. I guess I get the lesson. I'm not sure. Anyway, thanks for a great talk. Fabulous. I just want to tell you a short story of how an AI system adversely affected Old Guard in the last 3 days and how we triumphed over this AI. Okay, so here. Your talk was, we put postings in the local online media, especially the patch ones, each town. Okay. So we had one for you, and we're going to have, and Thad Gabara tried to post one for the January 28th talk, which is by the Honorable Joel B. Cohen. He tried to post it the other day on Sunday, and this was a beautifully written press release by Bob Beller, who was our monthly program chair in January. Impeccable English, and Patch, according to Thad, he says, I have a problem posting this item to Patch. Patch detected, quote, inappropriate language while I submitted the following article. Now let me read you a little bit of this. It starts off, it's 2 paragraphs, beautifully written. It says, on January 28th, the speaker will be the Honorable Joel B. Rosen. Joel will discuss the challenging landscape in U.S. law, including the notion of the rule of law, federal prosecutions, judicial review, and ethics. Judge Rosen is a former United States magistrate judge and a former partner in the firm of Montgomery McCracken and was a nationally recognized brother. It goes a little bit further, and then there's another paragraph about, our boilerplate paragraph about Old Guard. And he tried to post it several times, gets the same result. Somebody else tried to post it in another patch. So what's going wrong? I mean, it's impeccable English. There are no objectionable words. So I suggested to Thad, try this. Take that, split it in half, and submit each half and see which one gets rejected. And then split the rejected one in half and keep doing that, okay?
That's binary search.
Binary, and I said, that's called binary search, you know that. So he does binary search that way. And he says, Paul, I use binary search, and the word is united in the United States. And he's, I'm kidding you not. To post the write-up so that it will be accepted, change Judge Rosen is a former United States magistrate to Judge Rosen is a former U.S. magistrate judge. He did it, and it worked. Okay, so I write back, I say, I got a good laugh out of that. I guess that sums up AI. And I said, but maybe the subtler message is that after the recent election cycle, these 50 states aren't all that united anymore. So what's your reaction to all that?
I better not comment on the election. Fair point. And people who use this technology without understanding its limitations kind of run into challenges, and they don't know what to do, and it's an issue. It doesn't come with a big warning, right?
Yes. Hello. A good speech. I've had an ongoing discussion with someone in our group. I kind of follow AI, and my impression is that if AI gives an answer, unlike a program where you can actually go back and follow how it got to the answer, it is impossible to get to figure out how AI gave the answer. Is that true or false?
Yeah, I think that reflects your original point. Yeah, that is one of the major issues. You can't, the thing that's weird about these things is you can ask it, why did you come up with that answer, right? How did you come to, and it'll give you a pretty good explanation in many cases. But the fact is, that's not really how it came up with the answer, right? So it's pretty good at post hoc rationalization. The thing is, it can post hoc rationalize, if you will, almost anything, including complete garbage. And so you can't trust its tracing of what it did to give you an answer. And if you read the literature, there's really interesting things that are both positive and negative. You can, you've probably heard the word prompting, right? That's when you give it a natural language statement. It could be long and complex. That causes it to give you an answer. And you can write a very elaborate prompt that says, pretend you're a United States Senator from Kansas and you've been in office for 10. You could do many, many things, and it can come back with an answer in that persona pretty well. But there's something that people call chain of thought prompting, which allows these systems, in some cases, you ask it a complicated, say, logical puzzle or math problem, and it doesn't do a good job. I have an example in the slide deck, but I won't bother you. It's one of these pour water from a 6-gallon jug, and again, just like the wolf and cabbage example, it completely flubs it. But you can give it as a prompt a series of steps that it can then mimic, and all of a sudden it appears that it can solve those complicated problems, which is really quite interesting. But also what that means is that it's very susceptible to suggestion, right? If your suggestions are good and lead it to more rational thinking, that's great. If your suggestions are lies or subtleties or slight misdirections, many years ago, you may have heard about a Microsoft system that was released called Tay. It wasn't, I guess you could call it a chatbot. It was released on the internet, and it was a query and response kind of thing, and they let it loose. And within a matter of hours, they had to pull it down, because you know how the internet works. People started teasing it and pushing it to say hateful things, and it became a hate-mongering program within the course of a couple of hours. So again, these technologies are very susceptible to those kinds of suggestions, which again makes them problematic in certain situations. Okay?
Fantastic talk.
Thank you, Herb.
Thank you. Well, in the early days of computers, there was a saying, garbage in, garbage out. I haven't heard much about it, but we've had colossal situations in recent years, decades, where one point of view was promoted and another was suppressed, declared misinformation on a grand scale. So the meaning of truth and the meaning of science is kind of fuzzy now. You got to use a lot of common sense when you make decisions. How does AI deal with this? It takes in all data, doesn't it? And how does it judge which is propaganda and which is truth? I have trouble.
That's a key question. And along the lines of what I just said, it doesn't make those judgments. It just gets trained. It's not taught, it's not educated, it's just trained in a reflexive way on the language that it's exposed to. And so you can give it limited training. You don't have to get a model from Meta or from OpenAI. You can build your own and train it just on very limited things. And it will, and I hate to use the words, kind of accept what you've told it as the truth, and then it will spit out, when you ask it questions, things from that corpus, that data corpus. But because the big models are trained on the entire internet, you know, there's stuff out there. Another challenge with this whole industry is that people will not reveal what their training data is. So even if you might not be able to explore how it's coming to a decision, but you might want to know, what did you read to lead you to think that in human terms? You can't tell, right? I want to say one other thing, and forgive me for this, but I think it's relevant. There was, I think, a faculty member, a professor, I think at Penn, who wrote a pretty famous paper a few years ago called On Bullshit. And there are people who have characterized ChatGPT and those kinds of systems as absolutely world-class bullshitters. And in fact, if you look at what it does, for example, you can ask it a college-level essay question, and you know how people who don't study and stay up all night drinking write a kind of BS-type essay to hand in that sounds very good on the surface, it's fluent, it reads well. This is what these systems are really, really good at. Now, of course, Meta won't tell you that, and Google won't tell you that, but I think it's a pretty apt characterization of what they're producing, and you just can't track what it is that they were trained on to understand what it thinks, and there's no notion of truth. That's why when I said at the very beginning, machine learning is not the same as all of AI. If it were, we would be in dire straits forever. But there are other things you can do in terms of rational reasoning mechanisms, complementary perception mechanisms, conceptual bases that you would add that in someday I hope will make it more robust.
Let me just say something from computer history. Garbage in, gospel, garbage in, garbage out, but how about garbage in, gospel out? Gentlemen, this is the most inspiring, educational, and up-to-date I've felt in a long time. And it's just a wonderful talk and discussion. Thank you for giving us this time. Thank you very much.
Ron, let me second that. That was terrific. Prior to this talk, my plan was to use ChatGPT to enhance my life story. I've decided not to.
It'll probably do a very good job.
Yes. It'll make me sound like Waldo Emerson. We have two ways of thanking you for this great presentation. The first is with this certificate of appreciation. And as you can see, it includes a picture of an orchid, which is a symbol or icon for the old guard. And the reason for that is that when the old guard was founded in 1930, Summit was the capital of the US for orchid distribution and growth. Okay? And the second way is with the old guard salute.
Thank you.
Terrific, Ron. Appreciate it. Okay.
Thank you all very much.